Bismillah ar-Rahman ar-Rahim. Today we will start our discussions on quantitative methods. And obviously, when we go for quantitative studies, then we need to deploy various kinds of methods, including the sampling methods, and later on we'll talk about some analysis methods as well. So, in research design, a step on the way from research questions to finding. So these are the various steps which we have to do. We can connect these together. Obviously, the research questions, we need some research questions because that will decide that what actually you want out of that research. So that will help you to find out the results, the output, and then that output can be verified. So research questions, whenever we have our research problem, we write down some research objectives which are broader in a sense, and out of those objectives we pick out various questions. Then obviously we'll apply, we will have some sort of a research design. What is the methodology we have, what type of approaches we will use, how we will collect the data, what type of data we have, whether we have all quantitative data, what type of attributes we are dealing with, how you relate various attributes together, what is the source of the data. All these things are important. And of course, whenever we have the data, we apply the analytical methods or analysis techniques on that particular data. That is not necessarily the statistical analysis, but we can talk about various computational techniques, computational methods, various other approaches which you might use to analyze the data, starting from basic descriptive statistics to probabilistic modeling to stochastic modeling to network analysis, so on and so forth. And obviously, that will converge together to have the findings. And obviously, once we have those findings, only then we can see that how we have achieved our goal and how we deviate from what we have started in the beginning, and what foundation we let down in the beginning. So we'll see how our findings are related to it. That will help us to conclude. So, uh, for forms of various quantitative data collections, which is important, which we should know, and which we might use during our research process. Number one, controlled comparisons. Controlled comparisons involved some sort of experiments. But obviously you cannot apply this in all the domains, in all disciplines, or whatever type of research you have. So you can build those comparisons in a certain environment which you create yourself. That is why it is called controlled, because you have your own definition and you have your own design of the experiment, so that you know exactly how that data can be used and how you can apply certain methods to it. The second approach we talk about here will be talking with the people, which is very important. That we have to interact with the people who are concerned. So the people who are concerned, how we can reach them. The most common method for doing this is a survey approach, that you connect with the people using a survey, because survey, as you know, mostly is a structured technique, and you exactly know that which variables you will consider during the survey and how you will relate those various variables. And there are various standards of surveys. We have to apply one of the standard which is there, and then we have to choose with the Likert scale and other things, and then we'll try to execute those surveys to collect data wherever we think that there are a number of people who are involved. Then we talk about observation. Observation is also a very important phenomena in the research, because sometimes we collect the data, but observation is very important, that how things are happening around us. For example, you want to develop a banking application. Of course, all those customers are quite relevant, or all those customers or account holders you might consider, those who are interacting with the bank, or even the employees who are working in the bank. But it is very important to see that how that system is working. So observation will help you to know that how people are reacting to it, how is the waiting time, what type of environment is being created over there. So observation help you to come out with the conclusion. It can be unstructured, it can be structured, but here the most in the research we focus on the structured observation, where we write down all those important elements, whatever we consider during that observation process, using existing quantitative informations. One, secondary analysis of existing survey, that is called the microdata. For example, you have that data which is being you record it using a survey approach. So you need some secondary analysis of that data. It is called the microdata, and you apply various statistical methods to know exactly how that data is behaving. You might be interested in various groups. You might be interested to form various clusters or classes, or you might be interested initially in frequency distributions and basic statistical approaches in the beginning, to find out that how that data behaves. Ultimately, that is not what is required as the output. But initially, of course, you want to know exactly how that data is behaving using existing quantitative information. Second step, where you'll go about analysis of existing published quantifiable data. So there are a lot of data which is being used, and which can be used, which can be downloaded, and where various people have worked on it, and that is called published quantifiable data. And you have various sources, just like Kaggle. If you have visited Kaggle, you can find out that there is lots of quantifiable data which is there, and that is all reliable data and in the standard format. So that can be used in the research as well. So let's suppose if I am working on similar problem, let's suppose in a Pakistan domain. So there I can also collect my data here by using various approaches, and also I can have that data available from various published sources, and I can see how that data will behave, and I can compare it. That will really help me to come out with the conclusions. Looking at textbooks, films, web pages, advertisement, that is called content analysis. It is not necessary in all the disciplines or domains, but let's suppose if you have some problem which involves, let's suppose, natural language processing, or you are working on some problem which is related to news management, or maybe any concept which you want to know exactly how that concept is being built, or how that propaganda can be developed, and you will try to relink it with various published resources, so either on the web or the print, then you have to go with that content analysis approach. Otherwise, it is not necessary everywhere. What do social researchers lose by not carrying out experiments? So that is something which you try to understand, that experiment is a scientific method, as you know. So as a scientific background we have, we always believe in experiments. We always believe in results, and we want to see exactly how it works. So because that is a basic approach. So without conducting an experiment, if you just only come out with the theory, people will not accept it. That is the scientific approach. So we need some evidence. So obviously that experiments help us to provide the evidence, the output, and then we can realize whether it works well or wrong. So in an experiment, a sample of people could be allocated at random to two groups, one of which could be subjected to a treatment. So there are various ways by which we can have that experiment. We can form various groups, and then we can see and relate those various groups together. For example, in terms of unemployment, frequency of some outcome, for example, their social connections, maybe their marital relationships, and maybe their economical structure. So it basically helps you to have various groups and see that how those various groups responded to various situations. However, in reality, the reasons one can only observe whether unemployed people are more likely to experience marital dissolution than other people. Now, this you have to prove. This is not very general. So we have to, whenever we conduct that experiment or whenever we conduct that study, there we have to include some parameters and see that in the given parameters or in the given scope whether it is true or not. So we have to come out with certain population, and we cannot make a statement about all the population, but in fact we look for a particular study in a given scope and in a given domain. So we might have different results over here in, let's suppose, Southeast Asia, and the same study, if is conducted somewhere else, let's suppose in Europe or North America, you might have different results. So this is something which we have to understand, that we have certain factors which we have to be included. And obviously, those factors are very important, and those factors can be treated as an attributes. So, what attributes do you think which is important, which are relevant? And there might be different kinds of relationships. Not It is not a univariate problem, but sometimes it becomes a multivariate problem, because it involves not only one variables. We cannot only decide only on the basis of one variable, but you might have various variables. So you have to identify those various variables, and then you have to relate them together. So um, it is thus important to control for other factors that may have induced on observed relationships. So that those are called observed relationships, because you have taken certain population, you have recorded some input from that particular population, that is called observed relationship, that how they behave. Controlling for such factors inevitably involve the use of multivariate analysis, which involves three or more variables, in the case four relating to unemployment, marital exclusion, class, and age of marriage. So it means that, let's suppose we have these various variables together. Let's suppose mm, here we want to have a study in for example, in our scenario, let's suppose we want to study that how vaccination, how with different groups of people have different reactions against those vaccinations. So we might have various groups. We can make various age groups based on certain variables, and then we see that how they react to those COVID vaccination in Pakistan, or what type of reactions they have. So we can understand that how they behave. So sometimes we have to deal with the multivariate problems. So some of the approaches on an earlier slide involve unobstructive method. That is, they tend to not to involve the artificial, potentially power-laden and much criticized interactions found in survey interviews. So that is called unobstructive method. Why it called unobstructive method? Because there is no ambiguity. So whatever we have, whatever the information we have, we can depend on it. So that is called unobstructive method. um, uh, because it is mostly that information is retrieved from the survey or either the interview. However, all the involve the operations of concepts and coding of data, and may involve decision in relation to sampling, and so much as are not immune from criticisms aimed at processes and the subjectivity involved therein. Of course, whenever we are dealing such problems, people might ask that how you have collected that data, from where you have collected that data, what is the population size, how you have decided about the subjects, because the first question normally raised whenever we are performing such studies is the question of biasness, that okay, you have done this study, but there is a clear bias. You might have looked into the population of similar people. You might have taken data from similar group. living in a similar domain. So they might have their own point of view. So you cannot generalize it. So it means that as far as statistics is confirmed, that is not a problem. But the problem is that how you justify the data which you have, what type of sampling method you have used actually to look into that problem. So you have to obviously respond it scientifically. You have to have an argument in line with your research, so that you can reply to the people. You can say that, okay, no, this is the method by which we have collected that data. That is the population we have. That is the samples we have. Sample and population. The range of statistical analyses of a sample can be carried out, including descriptive analysis. Um, uh, First thing, which is very clear, that when we talk about a population is a bigger in size. So, population, you might want to do a research including all those people who get vaccinated, but obviously it is difficult for me and for you to conduct a study, because in Pakistan that figure might be might be 300 million. So let's suppose 400 million. So reaching out to 400 people is merely difficult, because in a given time frame we have to conduct that study. So sometimes this is not possible to reach out to 300 million or 400 million people. So that is the population we have. Let's suppose if we want to have a study related to vaccination in this COVID scenario in Pakistan, or take any other example as well. For example, you want to have apply some, for example, mHealth solution or eHealth solution, or let's suppose you want to develop some sort of application which is used in healthcare. Even then, you cannot go for all those instances which are there. It is not possible for you, because there may be thousands of instances over there. There may be million of instances over there. You cannot go and find out all those instances. So even you look, your population size is bigger enough. So what we do then, we look for a good sample. That is very important in research, because if you are doing research and you don't know how to sample it, then it will be difficult for you to defend your research, because the question will be raised. Because in a research design, it is very important that you should know that what type of research involves how much sample, and how that sample can be collected, so that must be unbiased. So so what we can do, whatever we do, we apply those statistical techniques or mathematical techniques or computing techniques on those samples, and of course, whatever the results we have, that is very close to the population. However, the topic of interest is typically focused on some feature of the population, but we are normally interested in some feature of the population, not all the features of the population. Let's assume that here we are interested in, for example, the responses of the people in this vaccination scenario. So here also we'll focus on some of the aspects that might be related to the health, that might be related to the psychological issue, that might be related to some fear or other characteristics. So those features which are also important or relevant, we only focus on the given features, not all the features. So therefore, statistical analysis usually involve the use of techniques for making inferences from a sample to the corresponding populations. So if you have a good sample, you can make an inference, and whatever the inference you will make, obviously that inference will have the same influence on the population. So that is good research, how we can make such an inference regarding the corresponding population, and only then we can have a statement that we can say that the reaction of that particular group in Pakistan is this. How you can do this? You can prove it by your statistical analysis or computational techniques, and obviously that is based on the samples you have. So, and only then you are be able to make some conclusions out of it. And your conclusions are obviously based on those inferences. But it is quite possible that we might have a sampling error. If we have a sampling error, that then there is a problem. So most pieces of quantitative social research rely on samples, but the most carefully designed sample will never provide a perfect representation of the population from which it was selected. So we based on samples, we rely on samples because we cannot move on and to have a research. Let's suppose we want to see how vaccination impact the immune system of humans. So what we do, we will try to have a data of, let's suppose, 300 people, 400 people, and then we can make the statement, or then we can have an inference. We cannot go and find out the data of 1 million people or 2 million people. We can do this, but this is not possible in a limited time. So for that purpose, you need to have more resources. You have more money with yourself, you have a bigger group of research, your bigger research group, and you have been funded heavily. Only then you can go for the large population size. Otherwise, in the research, normally what we do, we go look for a good sample. But even then, if we apply a very good sampling techniques, even then we cannot say that it is a perfect representation. So let's suppose if you want to know that how the students of UBIT feels about the educational standards in UBIT. So even if I talk about, let's suppose, 100 students, and then I make a conclusion, although that sample is not that bad considering the total size of the students, but even then, whatever the representation I have, that is not the perfect representations. So normally you see that you can have various representation on the television channels whenever you see about let's suppose about political parties, and they say, okay, we like this or we like this. So whenever it is in the favor of one, they say, okay, this is in favor of us, people like us. The other one says, okay, okay, this sample is not enough. You have just talked about 4,000 people. This sample is not enough. This is if you interact with more people, or your sample size is different, the result will be different. Because, and sometimes the results also shows that whatever we have in the survey is not in the results. So it means that there is always a sampling error. But what we have to do, we have to control that error. If that error is controlled, if it is in the limits, then it is okay. Then we have no problem, because it is a universal fact that any sample, whatever the sample you take, it is not a perfect representation of the population. So there will always be some sampling error. That is the key point which you have to consider while you are doing the research. But that has to be managed. In various problems, that sampling error might change. For example, if you are building any health application, let's suppose you have developed a decision support system in health domain, for example, using body sensor networks. So there, if you have a bigger sampling error, that is not acceptable. That is then they do not have the confidence on your system. So there, that confidence, that error has to be reduced as much as you can. Similarly, let's suppose if you are developing a defense related applications, let's suppose a missile development programs, or missile targeted programs, drone programs, there also sampling error or the calculation errors may be dependent on that, cannot be you can cannot be big. So however, the term is used in a specific way in quantitative social research if the sampling approach used or patterns of non-response result in some degree of bias in the result, is this is labeled as non-sampling error. So what it says, that if the sampling approach used, whatever the sampling approach used, will talk about those various sampling approaches, and you might have idea about those. For example, You might opt for simple random sampling. You might opt for a stratified sampling sample modeling technique, or you want to use a probabilistic method for sampling. It's up to you what type of sampling you want to use, or method or approach you want to use. So if even you are going for the sampling approach use, or the patterns of non-response where you do not have a response, results in some degree of bias in the result. So it also come out with some degree of bias which is there. Uh, but that is not sampling error, as it reflects a deficiency in the sampling approach. So deficiency in the sampling approach is a different thing that can be controlled. So once you have that deficiency, that can be controlled. That is not actually the sampling error, rather being an inevitable consequence of examining a sample. So how you have examined the sample, that is a different point of view, and how you have collected the sample is a different point of view. So you might have an error, sampling error, that leads to the results which may deviate from the actual results, or it might deviate from the overall representation of the population. So we have to be very careful about design of finding out those approaches, and then how we can use those samples for the research, and how to eliminate a bias. Parameter. A parameter is a quantity relating to a given variable for a population. Example, normally we say about the average or max or min. These are what? These are various parameters which are being involved uh, for any particular variable. We talk about we talk about the average age might be. We talk about the various uh, other health parameters, or even if you're not talking about health, let's suppose you talk about a financial problem, you might talk about various things like GDP, GNP, the foreign currency rate, so on and so forth. So there are various parameters which is involved, and obviously whenever we're dealing with those parameters, we deal in terms of a quantity. uh, when researchers generalize from a sample, they use sample observations to estimate population parameters. Okay, normally what we do, we generalize something. Whenever we come out with our conclusion, we just try to generalize. We want to say that mostly this happens, or we try to prove our theory, and obviously we generalize it from a sample. So we need some observations what to do to estimate the population parameters. So instead of, let's suppose, instead of going through with the census, exactly, census gives you the exact value. uh, So when researchers generalize from a sample, they use sample observations to estimate population parameter. This is what I have discussed earlier on. So when we make those generalizations based on those samples, and obviously whenever we make those generalizations, it means we are talking about the population parameter. The sampling error for a given sample design is the degree of error that is to be expected in making these estimations. I just want to quote one example, that here in COVID situations, there are a lot of fears in the mind of the people. So if you go for the vaccination, there are give different vaccinations which are there. Some are DNA based, some are RNA based. So some people might say that okay, if you go for this particular vaccinations, you might have the blood clot, but nobody has the evidence. But there are certain studies which are being carried out in Europe and North America. They have a study, and they formalize that even in from 2 million people, there are 3 people or 4 people who are having that problem. So they have that data with themselves to generalize it. So you cannot make a statement about something, you know but obviously whatever we feel, or whatever there is false the element of false news in the social media, we make those statements without any evidence, and people start accepting it. So we have to come out with a proper research and then say, okay, no, this is the case. So in Pakistan, there might be a different rate. Why? Because we are different people. We have a different chemistry. physically we are different. We are having we are having different hygiene. We have different habits. So it is very important to know that how people in Pakistan actually reacted to those various kinds of vaccinations. So here we have to work on those particular population size and groups, and to determine what type of sample is required to generalize. So people are working on it, and there are some researches which are published in recent times. So the sampling error for a given sample design is the degree of error that is to be accepted in making these estimations. So now there is something which is acceptable and there is something which is unacceptable. So if sampling error is too big, then obviously your supervisor will say that I'm not convinced because the sampling error is too big and you are making a generalization. So that generalization is not acceptable. So you have to see your research method where you did wrong. What actually went wrong with your research that you have that much sampling error. So what we have to do, we have to reduce that sampling error in the acceptable range. And again, I cannot give you a number because every domain and in every real life problem, we might have different error range. So I cannot give you a number. That has to be minimized. That has to be minimized. For example, if you say that my error rate is sampling error is 0.05%, that is very much acceptable. If you say my sampling error is 1%, that is very much acceptable for some kind of problems. So the parameter estimate generated by quantitative research are equal to the population parameters plus a certain amount of sampling error. So whatever estimates we have, it is almost equal to the population parameters, and the additional thing is what is the sampling error plus any bias arising from the data collection process that has to be determined. That is called bias normally happens whenever we only consider a certain group of population intentionally, or we collected data from let's suppose from where we have the access, or so that will create a bias. Or we have collected data from the people whom we think that they have that particular problem, so we need to prove our results, so we look only for that particular samples and then try to prove, okay, whatever I'm saying is true, whatever my theory is that is true, whatever my hypothesis is true. So that is called a bias. So we have to see that how you have collected your data, what how you have applied a method for data collection so that there should be no bias. So there can be a sampling error or a bias, and that will deviate you from actual findings. So with this, I conclude over here, and we'll start the next session after 5 minutes. Thank you.